Thanks, everyone. Thanks for joining us for the final webinar in our Ensuring Quality Heat Pump Installation series. So today we're going to be looking at verifying F280-12 load calculations for heat pump installation. We've extended this webinar, same as the last webinar, by 30 minutes, just to allow ample time for your questions at the end. But we'll get started right away so that we can take full advantage of those 90 minutes together. All right, so just forward a slide there, please, Rob.
Sorry, Jenna, did you say you need me to move the slide deck?
Yes, please.
Sorry. Okay, here you go.
That's okay. All right. The Community Energy Association, we acknowledge that we carry out our work on the traditional and ancestral territories of Indigenous peoples. So through our commitment to truth and reconciliation, we support First Nations, Inuit, and Métis communities in taking climate action and reaching their goals of energy sovereignty, security, and resilience. So I'd just like to begin our session today by acknowledging the Indigenous people from all of the diverse and beautiful places we are joining from. So I'm joining from what is now known as Nelson, but for thousands of years has been the traditional homelands of the Sinixt Nation, the Silks Nation, and the Ktunaxa Nation, and is home to the Métis and many diverse Indigenous people. So I'd just like to acknowledge with deep respect and gratitude that it is in thanks to their generations of stewardship that we're able to enjoy these mountains, forests, and waters in the way that we do. As part of my commitment to truth and reconciliation, I am educating myself about the history of colonization and the cultures that were lost. And I'd like to take this opportunity to challenge you to embark on your own journey with truth and reconciliation. I know we're all at different stages in this journey, but this challenge is inspired by a speech delivered by Jason Eagle Speaker as part of the IRCC citizenship ceremony. So it's a challenge to learn what you can. Research the unceded Indigenous territories that you build, work, live, and play on. Seek out authentically Indigenous books, publications, and websites, and educate yourself about the treatment of First Nations people in residential schools, the 60s scoop, undrinkable waters on reserves, broken treaties, the thousands of murdered and missing Indigenous women, and the 94 calls to action from the Truth and Reconciliation Commission. So I've started my own journey with a book by Bob Joseph called 21 Things You May Not Know About the Indian Act. And I think it's a pretty eye-opening book for you, regardless of where you are on your journey. All right, we'll just move forward. Slides there, please, Rob. All right, so who are we? CEA is a registered charity and nonprofit. We're committed to accelerating bold action by local governments and Indigenous communities related to climate and energy. We have an unwavering commitment to our clients to provide services and support on their journey from awareness to plans through to implementation. So what does that have to do with kind of these workshops around high performance building? Well, in BC, buildings are the third highest greenhouse gas emitters. So for us, building better is climate action. All right, and we'll just move forward there. Perfect. So the Kootenay Clean Energy Transition is the project that this webinar is brought forward today on behalf of. So KCET, or the Kootenay Clean Energy Transition, is a project that was developed to address shifts happening in the energy efficiency, renewable energy, and home comfort space. So through KCET, we want to help Kootenay and boundary communities prepare for a more energy efficient and healthy future through training and capacity building sessions like this one. So thanks to the generous support of the organizations you see listed at the bottom of the slide there, we're offering this free webinar as part of that education piece. So to see the full list of upcoming workshops and webinars, make sure to visit our webpage listed at the bottom of the slide there. So communityenergy.ca/built environments. So you'll see an opportunity to sign up for our high performance building newsletter that comes out every 2 months to highlight news and events around new builds and retrofits across BC. All right, next slide, please. All right, and for those of you on this call who are doing retrofits, I just wanted to introduce the Home Performance Contractors Network. So if you're doing heat pump installs, window and door retrofits, or insulation upgrades, and your clients are wanting to access provincial and utility rebates, this is the network that you want to join. So becoming a member involves industry-specific training. Upon completion of the training, you can receive training subsidies and cost back for the courses. Recently, HPSC partnered with TECA and BCIT to offer a micro credential for a residential air-to-air heat pump specialist. So if you have any questions about the Home Performance Contractors Network or the micro credential, feel free to reach out to Brady Sturgeon. You'll see her email there on the slide. All right, and then final slide there before I pass things over to Rob. To sum up this slide, CEA is committed to providing educational opportunities to everyone, regardless of their existing knowledge or experience. So it's really important to us that we provide a safe and open space for attendees to engage and participate. So this slide is just an overview of some guidelines that we'd like folks to adhere to over the next 90 minutes or so. Most importantly, please just respect our speaker and other attendees on the call, and please don't hesitate to ask us any questions you have. We're happy to address them. So if you do have questions as we go through, we have added on 30 minutes extra at the end, but we'd still like to get through the majority of the presentation in the full hour. So if you have questions that are directly related to Rob's presentation, please raise your hand and we'll unmute you and you can go ahead and ask your question directly to Rob there. If you have questions that are maybe not directly related to the presentation or really specific to a project you're working on, we can address those at the end in that 30-minute Q&A period. So feel free to put your questions as we go through the presentation in the chat, and I'll kind of keep record of them and we'll go through them once Rob's finished his presentation. All right, so that's it for me. It's with great pleasure that I introduce Rob Pope. He's a senior consultant with Ecolighten Energy Solutions. Rob has vast knowledge and experience in the HVAC industry, and he's been involved with installing and servicing energy efficient systems since day one. So a huge thanks to Rob for joining us here today and for sharing your wealth of knowledge with us. So I'll pass things over to you.
Thanks, Jenna, and thanks everybody for attending. We'll just get right to it. Today, we're going to go through 4 major topics. First of all, introducing what F280-12 is, and following that, the importance of right sizing HVAC equipment, things that can go wrong. I'll give you some real life examples, and the options for F280 software, including verification and the key inputs using data for getting the right output for your load calculations. So here we go. First of all, what is a load calculation? And please forgive me, I don't mean to insult anybody who already knows what this is, but just bear with me. A load calculation is a method of determining the heat gain and loss of a building to properly size the HVAC equipment. Ultimately, we're all in the business of providing comfort, whether it's keeping you warm when it's cold outside or cool when it's hot outside. And that's what the load calculation does. It determines the size of the equipment we need to accomplish that objective. So how big should the heating or cooling system be is the question that F280 answers. It depends on a lot of things. It depends on many variables. So it's your insulation values, the types of windows you're using, orientation. We'll get into all of that later. But it is something that has to be determined by the right amount, the right inputs with an acceptable load calculation methodology. And I say acceptable load calculation methodology on purpose. And that's because there is only the one. It's the Canadian CSA F280-12. It's the only acceptable methodology for calculating loads in particularly Part 9 buildings, residential, under 600 square meter footprint and less than 4 stories. That defines Part 9 building. This is a nationally recognized standard. It's in both the National Building Code and in provincial building codes. In BC, for example, it's in section 9.33. It's required, although not enforced. You know, however, that's changing. It's pretty important that the residential space heating and cooling systems have the proper output capacity for obvious reasons. You know, you can't oversize it, you can't undersize it. Too little or too much can create dangerous and uncomfortable living environment. So what are the consequences of not getting it right? And here's a few. Reduced efficiency. Whether it's oversized or undersized, the efficiency is not going to be aligned with what the building needs. And so it's going to be inefficient compared to what it could be if it's sized correctly. Shorter life cycle for the equipment. So, something that is oversized is going to be short cycling, means it's going to come on and off and on and off more often than it needs to. And that by itself, among other things, but just that one thing alone, will shorten the life cycle of the equipment. It'll make it wear out faster, more maintenance and care is going to be required. Another consequence is increased costs and liability. So on the cost side, if a 3-ton system could do it, why pay for a 4-ton system? Why pay for that oversized ducting and all the associated costs with using a 4-ton system instead of a 3-ton system? Effectively adding costs when you don't need to. There's no point, right? And then there's liability. If you don't size the system correctly, you potentially have a professional and or financial liability coming from the homeowners. And that happens quite frequently. So that's one of the consequences. And of course, ultimately, poor comfort and poor indoor air quality. It's a big deal, and we want to make sure we get this the equipment sized correctly, and F280 is the way to do it. Current practices in the industry, we come from a lot of decades of kind of a complacency in the HVAC Part 9 industry in particular. There isn't really a universal set of standards, and there are bits of standards here and there, and there's certainly no enforcement of any standards, with very few exceptions across this country, especially in BC. So the most common practice has been rule of thumb. That's usually the HVAC contractor, kind of sizing up the house based on their past experiences. Sometimes they're right, but most of the time it's a coincidence if it's correct. So that's the most common practice right now. However, that's going to change. Less common practice, HVAC contractors referring to HOT 2000 modeling that's been completed by an energy advisor. Now, NRCan does not recommend HOT 2000 as an HVAC design tool. And we'll get into this later, but you can use HOT 2000 output for a block load, especially for a retrofit, to kind of align what your assumption is or what your own load calculations have told you is the heat loss of the building. The block load the HOT 2000 does, although it's not verified F280 compliant software, it will be close. If you do an independent a load calculation with compliant software, and you measure it up against a HOT 2000 output, it shouldn't be more than 10%. If it's under 10%, it's probably good. If it's over 10%, then you gotta check it. Something's not right. An emerging common practice in the HVAC contractors side of things is to use TECA, quality first load calculations. TECA is the industry organization for HVAC contractors here in BC. And they've created a F2 CSA approved, verified set of load calculations. And it is available to HVAC contractors for a much less cost than other softwares, with a much flatter learning curve. So it's more accessible, easy to learn, easy to get your hands on, doesn't cost a lot. And that's becoming more common. And that is good. It's a good thing. So that's emerging as a common practice. And the least common practice, of course, is the full consultation with a qualified HVAC designer, which typically includes your load calculations, cost benefit analysis, feasibility, all that kind of stuff, what your options are and what's the upside and downside of those options. And then, it's a design, an actual design and installation, quality assurance and commissioning and all that kind of stuff. It doesn't have to be an engineer. A PN is not necessary for the full package with a HVAC consultation. So rules of thumb. So I did this a while ago, quite a while ago, but for the area of the Kootenays. And I wanted to know if you do a Google search, and anybody can do this, you do a Google search and see what happens. And what I found were websites of pretty reasonably reputable companies with their ideas of what a good rule of thumb is for load calculations. The BTUs per square foot. And this is what we came up with. So one site, 30 to 60 BTUs per square foot. Another, in the end, that ended up to be 28 BTUs per square foot. We saw another one, I think this one was 22. Let's see, we had 22 BTUs per square foot. And here 25 BTUs per square foot. Okay, so let's take that and see what happens. So we took a house, we know everything about this house, we microanalyzed this house. And so for this case, we put this house in Nelson, and here's the loads. And we did it with 2 sets of performance standards, step 3 and step 5. So have a good look at the loads here. This, by the way, is a single family detached, 3,700 square foot and change, 2 stories plus a basement, climate zone 5. Nelson, 51,000 BTUs and change for step 3, and that's the heating, cooling 33.9, almost 34,000 BTUs. In step 5, it goes down quite a bit, 34,680 for heating, and it doesn't change much for cooling, it's 31,971. Okay, now let's do this with the rule of thumb and compare. So here we go. This step 5 house in Nelson, rule of thumb, 74,000 BTUs for heating. Right size at 34,680. And you can see, what the difference is and why that is a big deal using rule of thumb compared to sizing it right. On the cooling side, it's a similar situation. It's 31,009 and more than twice as much by rule of thumb. So this is the kind of mistakes that can lead to all those consequences that we just talked about. So what could go wrong? So here's an actual example. Just to give you a bit of context, I was contacted. They reached out to me because there was issues with this house. There was some, and something wasn't right. They contacted me to have a look at it and kind of do a peer review and give them some comfort that they were going in the right direction. So this is a step 5 house in New West. It's design, heating load 23,000 and change, cooling load 27,000, just under 28,000 BTUs. Now you can see there was an energy model done. There's the R values to the right. What matters though is this here. A load calculation was done. And this is what happened. The HVAC contractor was hired. The HVAC contractor did what HVAC contractors often do. They went to their supplier. Their supplier, as a loss leader, you buy my stuff. I'll do a load calculation for you, no problem. So they did it, and they came up with a design heating load of 63,000, almost 64,000 BTUs, in a design cooling load of 46,000 BTUs. Now, let me just go back and remind you what the actual is. See there, the 23,355 for heating and 27,695 for cooling. But this is what they came up with. Okay. Oversized heating by 185%, cooling 66%. So what were the inputs that created that discrepancy from one set of load calculations to another? Ventilation, for example, wasn't specified. We don't know what the air changes are. In the output, in the document that was provided by the load calculation provider, in this case, had no ventilation factored into the calculations. The foundation details were inaccurate. The room by room heating requirements were incorrect. So were the room by room cooling requirements. So here's the issue. First, the load calculations are done wrong, and that is the foundation for everything else. It is from those load calculations that you then determine your equipment sizing, and then you determine your CFMs or GPMs that you need to deliver the energy to the appropriate places in the house. That is how you size your ducting and piping and everything else. And if the foundation, your load calculation in the first place is wrong, everything that comes after it will be wrong. And here's an example how wrong it can go. So this is an equipment selection worksheet that was used based on those incorrect load calculations. And of course, you know that what they came up with was 100,000 BTU modulating gas furnace. Remember, this was a step 5 house, all electric, written right on the plans. Okay, 100,000 BTU modulating gas furnace. So then from there, from specifying the equipment, which tells you your, the CFM of the equipment, now you got to deliver that CFM through the building, right? And of course, if you're using the wrong data at this stage, you're going to end up with wrong duct sizing, wrong CFM targets, right? Both on the supply air and the return side. This is part of the procedure for a design, this step here, your schematic. This is telling you how much air to deliver, what size of ducting, what your pressure drops are, and all that kind of stuff. This is now all based on 100,000 BTU gas furnace. The load calculations were performed as a loss leader from a supplier. So here's the issue. They had no skin in the game, no liability, no responsibility. In fact, there's an indemnification right on their documents that says, we don't take any responsibility. That's the first red flag anybody should notice. Whoever is supplying those load calculations needs to have skin in the game, needs to have that liability and responsibility. Otherwise, it's meaningless. In this case here is probably, it's a loss leader, it's an inexperienced and unqualified designer. Which brings up another issue. We should be having qualifications for people doing these load calculations. There was no authority of jurisdiction to check or verify the load calculations, so there was no, no second set of eyes, no inspection, no verification from the authority of jurisdiction. And the certifying body in this case that gave that supplier a certification saying, yeah, they took the course and they passed, they're certified to do load calculations, didn't and doesn't follow up and create consequences like any typical professional organization would do. You create a certification. Now you want to protect that standard, right? Protect your branding. And so if people ignore or are not capable of meeting that standard, you want to stop them, and as a last resort, take away their certification, or at least retrain them and get them up to speed. So the bottom line for this section is you really need to calculate, don't guess, especially these days. there was a time, when there was no step code, and you build a code minimum house, if you built a house next door to it that was similar in size, and so on. You could, maybe if you were really experienced, guess it right. But these days, you look at a house and it looks the same, whether it's step one, step two, step three, step four, step five, net zero. It looks the same. Your thumb can't really distinguish all the subtle nuances that differentiate the energy performance of that building. It looks the same. It just has more insulation, better windows, more air tightness, that kind of stuff. So you want to calculate, because you want to, first of all, do what our job ultimately is to provide comfort and good quality indoor air environment. You also want to optimize the efficiency of the equipment. That's so that it doesn't cost you more than it needs to run. It has the least amount of carbon footprint, and it's going to last as long as it can last, right? You also want to size it right, because why spend more than you need to? Reduce your installed HVAC system costs, right? Don't oversize and spend more money if you don't need to. It's also ensuring compliance with the code. The code is actually already there. And it's happened where there's been issues, homeowners have, hired lawyers, and then warranty providers get involved and so on. Ultimately, it is the builder's responsibility to ensure the building is built to code. And if there is not a load calculation done as required in the code, then technically that is a legal tool that a lawyer could use. In the same vein, we want to reduce our liability risks. All these are good reasons to use proper load calculations, which happens to be F280-12. So industry trends. Mechanical designers, they, as I said before, they provide the whole package, consultation. They do the load calculations, they do the design, they do the quality assurance. They use software, they use more sophisticated software like RightSoft, which is expensive, it's not cheap, but it's worth it if that's what you're doing every day. It also doesn't just do load calculations, it's a design tool. It's many functions. And downside is a higher learning curve. But once you get past the learning curve, it's worth it if this is what your business is. Now, this is not right for everybody, but what is right is there's mechanical contractors involved in all installations. And for mechanical contractors, it's pretty a low bar to entry to take on the TECA Quality First companion software. It is F280 verified. It complies with the CSA standard, and it's not expensive, and it has a low learning curve. It's a really good tool for contractors or anybody to use. And then there's HOT 2000. A new construction, anything to do with step code has to have an energy advisor or an energy model done, right? So HOT 2000 will provide, it does do load calculations, but that's not its main function. Its main function is to model the energy performance of the house. And we'll talk about how we can make HOT 2000 work a little bit later on. So there is an organization called HVAC Designers of Canada. They're a national organization for residential heating, ventilation, and air conditioning across the country. They were tasked through Enercan and others to test the software that claims to be F280 compliant. So there was software out there, right, all claiming we're F280 compliant, but they all had different outcomes. You do the same house, same inputs, but all the different softwares, and they would come up with different results. And so Intercan and others said, okay, something's wrong here. Let's test all the software against a known factor. House in Ottawa, it's been monitored, data logged, sensors everywhere for a long time. We know what the heat loss is. So we measured it against that. We took all the software from the providers and did a hell of a lot of testing over the last couple of years and found out where all the glitches were. Went back to the software providers and said, okay, here's the problem. This is where your software works. This is where it doesn't work. This is what we think is the reason. And can you fix it? Can you make it compliant? And so that was done with 8 software packages, which are now compliant because this process has been ongoing for a while. Here's a list here of what's been tested and what has been verified to comply with the standard and have output results that are within an acceptable variance. So in other words, any of these programs work. But we're going to be talking mostly about this particular one, this one here, the TACA one I've mentioned, the right soft one I've already mentioned. And we're also going to talk about this one here. Remember, I mentioned how we can make HOT 2000 work with this particular program is how that happens. And I'll get into a little more detail in that a little later on in the presentation. So what's also happening with HVAC Designers of Canada is how do we bring authorities with jurisdiction to a point where they have the resources, the tools, and the capacity to verify load calculations. This is the reason it's not enforced in an overwhelming majority of authorities with jurisdiction right now. Things like they just don't know about it. They don't know about it enough to take it on and then take the risks involved with it. They don't have the tools. They just don't have the resources and so on. So HVAC Designers of Canada is going through a process with authorities with jurisdiction to do a few things. Find out what is the capacity of local designers to provide F280 calculations. How many calculations are required to meet demand for new housing? What barriers do plan examiners face for verifying heat loss and gain calculations? And how many warranty claims or other costs are related to HVAC design, and specifically the lack of correct heat loss and heat gain calculations. So this is a process that's ongoing right now. Basically, this is to ultimately tool up authorities' jurisdictions to enforce this requirement that's already in the code. Here is an example. This is a work in progress, but this is an example of a verification tool that could be provided to inspectors or authorities with jurisdiction, for example, right? Just a few things, boxes to check to see that the load calculation was done in compliance with CSA. And this is just one of the tools. So you can see it's actually in development. It's moving along and it's coming to an authority or jurisdiction near you soon. I mentioned this a few times. This is the most common used software currently. TECA is the BC Industry Association representing contractors and suppliers, Part 9 in particular. And it did hit its own, it invested quite a bit in did its own software so they could provide that software to its members, but not just to its members, to the industry in general, to HVAC contractors primarily. And it works well. BrightSoft. This is, for example, what we use, what we prefer to use, and we use them all, but BrightSoft is our preferred software because it's a very comprehensive design tool. It doesn't just do load calculations. It does all kinds of other things that we like. And but the downside is, you pay for we pay more. It's in annual license fees and all that stuff adds up quite a bit. And it has a high learning curve. But for us, because this is what we do every day, it's worth it. ECAD, similar to RightSoft. It is also popular. It is what the loop CAD was originally the first thing that we started to see on the market, and that was used primarily for radiant load calculations, for radiant heat and radiant designs. Similar to RightSoft, it's got a high learning curve, high license fees. It is very much a competitor of RightSoft in many ways, and it depends on your preference. I personally prefer RightSoft, but HeatCAD is a good alternative. Depends on your preferences. And then there's Hot 2000, and this is probably where most of the confusion I see happens when it comes to load calculations. One of the questions I get very often is, why do I need somebody to do a set of load calculations when I already have energy model done? The EA already did a set of calculations. Why do I need the HVAC contractor or somebody else to do another set of load calculations? And the explanation is this: Hot 2000 is not intended for and was not designed to do anything that informs a mechanical design. It's there simply to model the energy performance of a building. That's it. That's all it's supposed to do. Intercan itself does not recommend using Hot 2000 as a mechanical design tool. It's generally used for block load, so you do the whole building. You don't do room by room by room. However, it is pretty good at calculating heat loss. Not good at heat gains. On the cooling side, it's way off, but on the heat loss side, it's pretty good because it uses more or less the same math and physics that F280-12 uses. And so say I'm a builder and I've got one person doing a Hot 2000 model and I have another person doing an F280 set of load calculations, it is a good idea to take them both and see how close they are to each other on the heat loss side, not the cooling side, but on the heat loss side. If the total heat loss of the building from both sets of software are within about 10% of each other, then you're probably good. If they're not, then something's wrong either with the energy model or the load calculations. It has to be aligned. Now, as I said, it's not F280 compliant. However, there is a workaround. So Volta created a spreadsheet program that takes the inputs from Hot 2000. So somebody's already done an energy model. What are those inputs? They had to, of course, input all your assembly details, installation values, window values, all the stuff that determines the performance of the buildings already in the Hot 2000 software. What Volta Snap does is it extracts all that critical information it needs, and then it rearranges it so that the output from Volta Snap using the Hot 2000 inputs is CSA F280-12 compliant. So you get a compliant output. And this is handy as hell for energy advisors to use, or third parties who have access to the Hot 2000 data software. So an energy advisor, if it provides the modeling package to a third party doing a load calculation or an HVAC design or an installation of any kind, they can take the data from the energy advisor, input it into Volta Snap, and get a load calculation out of it that is verified and compliant with the CSA standard.
Sorry to interrupt, Rob. I just wanted to give you a time check. We have about 20 minutes left in the
20 minutes off, okay.
Yeah.
Two kinds of loads. Block load, that's typically the Hot 2000 way of doing things, and room by room, that's the F280. It's okay in a retrofit to do a block load. Room by room is nice, but it's not critical. In a new construction project, it has to be room by room. You're designing a system. You're not using existing ducting, for example. You're completely designing a system from scratch. And you need to know how much energy to deliver and where to deliver it. And you turn that into cubic feet per minute, and that tells you what size of ducting and piping you need, and velocities and pressure drops, everything you need to know in the room by room. That's what you need to do. We've got this new home in Nelson, say. What kinds of inputs do we need to come up with what you see here? This is a snapshot of the load calculation, F280 load calculation. So I know it's pretty intuitive, but of course, the geometry of the building, above grade walls, and foundation walls, exposed ceilings and floors, exposed headers, windows, of course, skylights and doors, shadings, infiltration matters, ventilation matters, and internal gains. That's kind of what makes up the inputs to determine the capacity requirements for your equipment. If we do an existing home, this is an actual home in Roslyn, 1,625 square feet. You can see what the heat loss and heat gain is here. And these are the inputs that make up what the load calculation tells us. Walls, ceilings, it's all pretty well the same thing, but it's a block load and not a room by room load. Okay, so let's take this same house and analyze it a bit. Now, the blower door test in this house determined that it had a leakage at 50 pascals of pressure of 7.4 on an existing house. That's not that unusual, but it's pretty high. It would be unacceptable in a new house, of course. Again, we measured walls, ceilings, windows, doors, foundations. We can see here what the indoor and outdoor temperature design conditions are, and number of bedrooms tells you what the people load, occupant load is. Here's one of the first things that was flagged. This calculation was done using the climate data within the BC Building Code. And the same data is in the F280-12 software, right? And Hot 2000 uses a weather station of Nelson, or you have to pick a weather station that is close in resemblance to Roslyn. And the actual climate conditions for winter in Roslyn is actually a lot different than Trail. And that's just a common issue. You have to actually do your research and your diligence and check on the jurisdiction that you're working in to make sure that you've got the right climatic data input in the first place. So designing for the right location. So you can see here, this is a snapshot from the BC Building Code. There is no Roslyn, it's Trail, and it's the design condition is minus 14 Celsius, right? Minus 14 Celsius is in the software data for Trail. Here is the heat loss and heat gain using the climate data from the BC Building Code or the F280-12 software or the Hot 2000 software. Pick one. When the actual heat loss using the actual design conditions in Roslyn gives you a whole different picture, as you can see here. It doesn't affect the heat gain, but the heat loss is substantially affected. It's 11,500 and change difference, so it matters. Designing for climate resilience. So the design condition that is in the code and is embedded in a lot of the software is a bit out of date. If you look back for the last 5 years, you can see it's trending higher in the summer seasons, particularly. The temperatures are higher. And that's what I mean when I say designing for climate resilience. You've got to be careful. Design to the climatic data for the summer in that area is fine, but then you're going to manage client expectations, because the chances of it going above that temperature for a sustained period of time is high, right? So we like to design to a higher temperature. And you can see here how it's affecting the heat gain. At the climatic data condition that's in the code and so on, it's 31,148. In the heat gain, if you put some resilience into that, put that temperature up, which we do. Now it's a judgment call. It's not a formula. It's a judgment call, but it's a good judgment. It would put the load up a few thousand BTUs. Designing for client customization. So you're designing, unless it's a market built home, a spec home, right? You're designing for somebody. So you want to find out from that somebody what their idea of comfort is. It's different for everybody. Everybody's different. This was something that, I know is a long time ago. So you want to find out what's comfortable for them in the design to make them comfortable. So you can manipulate the load calculation. Again, it's a judgment call, but you've got to deliver what the expectations of the client is to a reasonable degree. And you can't go, you don't want to design a temperature of 18 degrees Celsius all summer long throughout the whole house, for example. That's out of the bounds of reasonableness. But you can see here, we changed the indoor set point from 75 degrees, 24 Celsius to 22 degrees, 0.2. That's kind of on the outside edge of reasonable. You can go a little lower than that for sure. But, once you get below 72, you got to really, talk to your clients about the implications. But anyways, just doing something as simple as going from 75, which is in most cases, from our experience, not what a client homeowner wants. Go to 72 degrees and you need another 6,000 and change BTUs. Designing for resilience, comfort, and efficiency. Infiltration is huge. We went from 7.41 to 2.5, which is your typical step 4 house, right? Or step 3 house. And look at the difference it makes. 9,800 BTUs, 23% drop on the heat loss. It also reduced the cooling load by 2,000 BTUs. It makes a huge difference. Knowing the infiltration is important because that impacts the loads quite substantially. The impact of windows. Let's look at windows. Here we have our baseline is a 2.03, which is a double pane window, really. Nothing special about it. But if we go to a triple pane window, 1.2, which is barely triple pane, you can get much better than that. USI 1.2 is a triple pane window. And look at the difference. We've dropped the heat loss from 32,900, almost 33,000 BTUs to 28,423. Big difference. 13.7% difference. Now notice it didn't affect the heat gain at all, and here's why. Solar heat gain coefficient. That's a very important factor. That is the filtering of solar gain coming in through the glass, right? We went from solar heat gain of, what was it, 0.3, or sorry, 0.41 was our starting point, our baseline. We went down just to 0.3. Solar heat gain coefficient is always measured in terms of 0 to 1. It's point something, you know, and 1 would be the clearest window you can get. And in fact, there's no such thing, but the higher the number, the closer to 1, the clearer it is. The closer to 0, the more filtering there is, and at some point you can actually see it's visible, right? You see the green gray tint, you know, at the opposite end of that spectrum. So just changing the windows from 0.41 to 0.3 reduced the load by more than 18%. It has a big impact, from 35,000 to 29,000, from a 3-ton to a 2.5-ton system. If we add these things together, which is usually what you do, you're taking all these little things and you're tweaking, adjusting, and tweaking, right? And what you end up with when you do all that, in this case here, this particular example, we see the results: reduced heat loss, reduced heat gain, better climate resilience, customized for the client, and better efficiency. It's all upside stuff. So to recap, for climate design conditions, building location and corresponding summer winter outdoor design data is critical. Indoor temperature and humidity set points, critical. Building orientation and type, you know, what's the geometry of the building. Infiltration and ventilation is critical. And building assemblies, of course, you know, above grade, below grade walls, exposed ceilings, floors, and so on. Those are all the inputs that we've already talked about that's important for a load calculation. So I think these are very useful links. HVAC Designers of Canada, if you're interested in where we're at or having access to the methodologies used or the compliant software, how, you know, the links to the software itself that's been verified, and also what's coming next in terms of tooling up jurisdictions with authority to help them verify the load calculations. These are the links you want to check out. They're very useful. There's also other useful links as well. Air source heat pump sizing and selection guide. Very, very, very useful guide. The Northeast Energy Efficiency Partnerships, which gives you a list of cold climate air source heat pumps that's been third-party tested, and it gives you a calculator. You take some of the inputs from your load calculations into a program that they have, and it'll show you from their list what equipment qualifies. Then there's AHRI. That is the third party that tests all kinds of equipment, heat pumps, furnaces, you name it. Third party tests them for its actual performance efficiency. It gives its efficiency ratings in COPs and heating season performance factors, SEER ratings, EAR ratings, capacity at different temperatures, all that stuff. And there's also the Home Performer Stakeholder Council. It is a great resource for best practices installation guide for existing homes. And that's it. How'd I do, Jenna? Get under the wire?
No, it's perfect. Thank you. Yeah, thanks so much for that, Rob. I know it was so much information, and you synthesized it perfectly in this quick presentation. So we do have some questions that came through in the chat. Are you ready, Rob? Yeah, okay. So Greg asks, in high temperatures, i.e. 30 degrees Celsius plus, can a freeze off be caused by an undersized system?
Sorry, can you repeat that, Jenna?
In high temps, i.e. 30 degrees Celsius or plus, can a freeze off be caused by an undersized system?
Yeah, Rob, Greg here. Yeah, just a quick question. Sometimes when it's really hot, I'll see a system where there's icing going on in the coils.
Yeah, that's usually, yeah, that is almost always related to airflow. The amount of air passing across that coil is not adequate for that, the refrigerant in the coil to change state, you know, so it's not absorbing enough heat and condensing the latent heat in the air. That's usually the cause. Of course, you know, if both or if the airflow is sized correctly and the indoor coil and outdoor compressor are sized correctly, it doesn't really matter what the outdoor temperature is. It won't be related. Issues will not be related to outdoor temperature if they're sized correctly. But usually, if you see freeze up on the coil, that's usually inadequate airflow.
Okay, thanks.
Thanks, Rob. And just a reminder to everyone on the call, just because we have a few questions coming through to this. Presentation slides will be shared with everyone on the call today, along with a link to the recording. All right, so our next question here, Greg just had a different Greg. We have a few Gregs on this call. Greg had a few just comments around municipalities inspecting heat load calculations. So a question here that I pulled out, he just asked, do any municipalities or technical safety authority conduct random site inspections to confirm A, an F280-12 was completed, and B, the system installed was per the correct F280-12 design? Do you have any knowledge around that?
There's a couple of jurisdictions, like in fact Roslyn, right, requires F280 load calculations. Kelowna does. There's not many, and no jurisdiction goes out and ensures that with the exception of Kelowna, by the way. For some reason, Kelowna's way ahead. And we're talking BC, right? Because across the country there are other jurisdictions that do that. Not many, but there are others. But in BC, there's with the exception of Kelowna, there's no follow-up after installation or during installation to verify that the system is installed to any real standard at all, unless it's a hydronic system. So plumbing inspectors typically will inspect them in a limited amount of jurisdictions, mostly in the bigger ones like the lower mainland municipalities.
Great, thank you. All right, Graham asks, seeing F280 calculations become more common is a great step forward away from rule of thumb. How common are residential commissioning reports in your experience? Having a system sized correctly seems like 75% of the solution. Making sure it is installed and functioning correctly is another issue. And just a comment here that Fortis might be requiring commissioning reports for future rebates, but in 25 years, I've never seen one done for residential.
Yeah, thanks very much for bringing that up. That's a pretty critical, important thing, commissioning. I think we do a whole workshop just on commissioning. I kind of think of an HVAC installation as a 3-act play, you know, and the first is your load calculations. It's pretty critical. You do your load calculations, you do your discovery, you find out what the expectations are, what the budgets are, the aesthetics, all that kind of stuff. You know, and then you develop a design strategy based on that. The second act is the design itself, right? And ensuring during construction that what's being installed is meeting the design intent. And the final act is commissioning, and then the handover to the homeowner. Now, even though in the scheme of things, commissioning is a small amount of work compared to all the rest of it, it is still critical. So much so that it, to me, represents a substantial portion of the, you know, a third of the total installation process from a point of view of importance, not of time involved. And like you know, you rarely see commissioning reports. When we design systems, we put into our design that the contractor is required to do a commissioning and a commissioning report, and still they don't do it. You know, we end up doing it for them half the time. But that's the shakedown. That's the period where you are measuring the performance of your installation relative to your design targets. And as anybody knows, you know, all the equipment is coming from a factory somewhere. It doesn't know where it's going to live, right? And so it's all default settings. You got to reconfigure everything, and you got to set up the controls, and you got to balance and tweak and all that stuff. And you got to find out if there's any defective components that you can, you know, you rush off to your supplier and get replaced before occupancy, ideally, right? Commissioning is pretty big. It also provides a baseline for future maintenance and repair, right? So the technician a few years later comes, sees the commissioning reports and says, okay, this is where the baseline was. Now let's check and see what's changed. So yeah, I'm glad you brought that up. Commissioning, I think eventually it's one step at a time. Right now we're working on load calculations, getting that into the authorities of jurisdiction, so that it's required in every jurisdiction, and that is going to come one way or another very soon. Designs to a standard that's acceptable will come soon. Commissioning reports as something to be inspected will come soon, just not as soon as the load calculations. They're in the process, but they will come. For sure, they will come.
Thanks, Robin. I'm just putting a link here in the chat. This was commissioning and performance verification was actually the topic of our, I believe it was our last webinar in the series. So I'm just going to quickly pop this in the chat here. So yeah, you can go ahead and watch that. Perfect. And Bruce just had a comment back to jurisdictions that require F280. So Nelson does require F280 calculations for new residential builds. So thanks for letting us know there, Bruce.
Yeah, the West Kootenays is actually pretty progressive compared to the rest of the province, which is really good to know. And I think in some cases we could use the West Kootenays as a template for everywhere else in the province in a lot of ways.
Great. And Jack, I tried to find this for you, but I couldn't find it either. Where can we download the Volta software?
I think, just let me see. I think it's in the link. Yeah, if you went to any of these websites here, I think the qualifying F280 software is the best one. Can you see that on my screen there?
Yeah.
Yeah, so that link right there will get you the link you need to the Volta software.
I just emailed them and then they set up an account for me and sent me like a username and password.
Oh, okay, that was quick.
Yeah. Well, not today. I was on the other webinar when they went over VoltaSnap, but I think that's the
Okay.
process to get it. Like you have to email them and let them know why you want it and everything.
Yeah, I think the intent was for it to be used specifically for energy advisors. Although I don't think it's, you know, practically speaking, will mostly benefit energy advisors, but I think anybody else can use it too. You know, if I was back in the days when we used to be contractors, I would have been happy to take the energy model from the energy advisor in the project and say, can you share that with me, and then put it into a program like this and output a result that I can trust. You know, that would have been pretty nice, easy to do.
Yeah, pretty handy. And Casper just comments too that it's a web application, not really something that you download. So yeah, you just need to request access to it. All right. Greg asks, why would you not be required to complete a room by room in a retrofit versus a new home? Wouldn't a retrofit have more variables by room that could directly affect the total load calculation?
Okay, good question. The one factor that differentiates an existing home from a new home is the fact that the ducting system is already there, right? So you're not really able to effectively, unless you're gutting the house and ripping out all that ductwork. If you're not doing that, then you can't really take advantage of the room by room and affect the amount of air delivery in each of those rooms, right? You're just stuck with what's already there. So what becomes more important then is checking the existing ductwork, making sure that the pressure drop that is inherent in the ductwork is within the tolerances that the heat pump equipment needs, which is usually not the case. In most cases, it's too small for the heat pump you need. Not always, but in many cases it is. You got to find that out and then mitigate that somehow or another. The other thing too is, you're really, unless you're opening up walls and ceilings, you can't really do much to the ducting. So that's why a block load is more reasonable than a room by room.
Okay, thank you.
Jenna?
Yes.
Yeah, sorry, I just wanted to ask one more
I'll
question
follow
on
up
that
there. Yeah,
topic.
go for it.
So I guess I was referring more to the windows within each room, Rob. On a retrofit, the size of windows, especially if it's a single pane or old dual pane window, I would think that it greatly affects it, but maybe I'm wrong. And then the other side, you were recommending, is it a static air pressure test then? Is that what you're recommending for a
Yeah.
retrofit?
Yeah.
Okay. It's a great idea. I don't know anybody that does that.
Well, okay, so first thing, yeah, you are correct. Windows will affect the load, right? But the thing is there's not really much you can do about it. The ducting is already there. As I said, unless you can affect a change, then the room by room doesn't really tell you or inform you. It doesn't inform your design choices because the design's already in the house, right? What it can do if you are in a situation where there is some flexibility, access to the ductwork, willing to open up walls and ceilings, maybe that's when it becomes valid to do the room by room, because you can actually affect change in the delivery of comfort, based on those room by rooms. The other thing too is an external static pressure test. Yeah, extremely rare. Now, don't forget, we are coming from a long period of time of, as I said, complacency. Some would call it the Wild West. Basically an industry that has kind of slipped through the cracks, unlike others like that have safety authorities like electrical, plumbing, structural, all that kind of stuff. HVAC has had no standards of practice. There's no bar to entry to become an HVAC contractor, right? And the consequence of that has been, a race to the bottom, more or less, with exceptions here and there of very conscientious contractors who refuse to do that and maintain a high standard. But those are the exceptions. Those are the exceptions. And the reason you don't see or never seen that external static pressure test is for that reason. It's just, if nobody's asking for it, then why do it? Why invest a couple $1,000s in the equipment and take the time to do it if your competitors aren't doing it and their prices you're already in a competitive market, right? That's the reason you don't see it. There are a few out there that do it. And like, as I said, they're the outliers though. But it's something that will be required eventually, because you like the period of time where guessing, rule of thumb, and that kind of stuff was acceptable is over. It's changing, right? And like changes I've seen, I've been doing this since the mid-70s. There's always going to be people kicking and screaming and, crying foul because, they're disrupting the industry and forcing change, right? But, if we didn't have change thrust upon us in regulations, we would still be lighting fires in caves, right? It's just the way it is. The industry doesn't like change, and unless we impose change, it won't happen. And right now, we're starting to impose change. We have energy standards. We have high costs. It costs more to oversize or undersize a wrong size system than it does to size it right. The cost of doing those load calculations and your due diligence for energy or static pressure measurements, for example, blower door tests and everything, the cost of doing that is a lot less than the cost of getting it wrong and all the issues that creates.
Okay, thank you. And what about the case where you're installing a ductless heat pump in a retrofit scenario? Would you do a room by room then?
Good point. Yeah, that's true. Yeah, because the ductless heat pump can only heat the room it's in, really, or whatever. It can't go down a hallway, can't go up the stairs, can't go through doors, right? So it can only heat the area it's in, whether that's one room, two rooms, or three rooms, as long as they're open to each other. And so you do need to know what the load is in the spot where that ductless split is going to hang. So yeah, thanks. That's a good point, Jenna.
Yeah, of course. Greg, do you have another follow-up there? Are you happy? I think we're good.
I'm good, thank you.
Okay, great. All right. Another Greg asks, I've seen a huge solar heat gain load for west-facing large area double pane windows. Can a ceramic film affect the solar heat gain coefficient to make it cost-effective payout-wise?
A ceramic filler?
Ceramic is in
Did I hear that
quotation
right?
marks, but a ceramic film, yeah.
Oh, film.
Yeah.
Okay. Anything that blocks solar gain will do. Window manufacturers put that on the panes of glass. And once you get, if you stay above 0.3, 0.26, 0.28, you can't even notice it. You can if you're really sensitive to it, but it's hard to notice it. So there's that works well. And then there are other things. There are things like blinds. Internal blinds, for example, don't work as well as external blinds. Once the heat's through the glass, that blind becomes a heat sink and reflects that heat into the occupied space. And so any kind of device that is internal in a building that can filter or stop the radiation from solar gain coming through will work to a degree, as long as it doesn't absorb the heat and it becomes saturated with the heat and radiates that heat inbound to the house. If there's going to be something, something solid or semi-solid, semi-opaque, translucent, it doesn't matter. It should be on the exterior of the building. So it's stopping it before it gets in.
Wonderful, thank you. And Greg asks, in terms of outdoor heating, cooling design conditions, would you recommend ASHRAE climate design conditions?
Remember I said you got to use a little judgment. At the very least, you need to use the climate data that is in the code, but if it is not, if it doesn't cover every little town in the province, you could, for example, here's a good example, Cranbrook is the weather station closest to Kimberly, right? So everybody uses Cranbrook. Kimberly is way the hell up the mountain. It has very different climate conditions. The same is true between Trail and Roslyn. There's all kinds of conditions. Whether it's an east-west or north-south valley that you're in, where you are in elevation, and all those things matter. So if it is not specifically in the BC Building Code, you need to reach out, and usually it's published on their websites, to the town or regional district or city, and get specifically what is the climatic data for that particular location, and use that. That's your minimum required climatic data inputs that you need to do. And then after that, it's just judgment. And what we do, and after a while, there's no effort. You take the climatic data from Environment Canada for whichever area you're working in, wherever that project may be, and you look, because the data is very available, and you look through. We just import it into a spreadsheet, and we can track it however we want and look through what is the trend. Is it going up? Is it going down? And if it's going up, of course, you want to adjust for that, because it may not necessarily be in the climatic data that is published in the BC Building Code, or even in the particular town or city or district that you're in. So there's a little bit of judgment on that you have to apply.
Yeah, and Todd comments that Roslyn does have its own climatic data, but it's not in the BC Building Code. So
it's not. You have to
please
look it up. Yeah.
Yeah, so you can call the building department. Data is needed.
It's not, yeah, or it's published, or you can just go to Environment Canada, and look at the data yourself, right? It's very Environment Canada keeps data for everything, lots of it. Just and access to it's pretty straightforward. So you can do that, or you can call. Sometimes a simple phone call, it's the quickest way to get it, or just on the websites like Rosalind has. You can get it from their website.
Perfect. Wonderful. Thank you. We just have our last question here. We still have 10 minutes left in the Q&A. So folks on the call, if you do have more questions, feel free to pop them in the chat or raise your hand. But here we ask, it's kind of a two-part question. Are there too many tools in the market that don't talk to each other, and so it creates confusion and non-compliance? Are there efforts between the organizations to harmonize the requirements and inputs and facilitate the data exchange?
Nice question. That's a good question. Okay, so it's starting to happen that harmonization is coming together. So, for example, this last couple of years, and I had the privilege of being on the CSA committee doing this. We, once it became clear that, hey, we have all the software that says it's F280 compliant, but it's not. Let's get that sorted out. So now that's sorted out. So that's an example of something that works, something that's been harmonized. The F280-12 software, if you consider that a tool, that at least is been harmonized. There are various agencies, like in Part 9 buildings, you can go to the ASHRAE standards, you go to HRAI standards, you can go to TECA standards. There's various other standards, and none of them are harmonized, except we did publish recently a CSA document where we created what is called a builder's guide for HVAC for Part 9 buildings, and in that guide there is a set of standards. So we're starting, that is being rolled out. That was published just less than a year ago, actually. And now it's being rolled out by all the agencies that supported it. So it's provincial across the country, national and regional and utilities and so on, who supported that process to develop that set of standards, is now behind unrolling it throughout the country. And that will eventually be embedded in the National Building Code and in provincial building codes. And so that's on its way to being harmonized. So yeah, so there are, tools out there, and we're kind of in a time of transition right now where we're going from unharmonized, conflicting tools and resources to harmonized, coordinated tools and resources. So it's still a little bit of the Wild West, but it's they're on a positive note. I wish I was many decades younger, because it's an exciting time to be in this industry. I think a really exciting time. It's a renaissance that's happening right now.
Great, thanks. And we did do that was our first webinar in this series back in January, I believe, but we did a webinar on the HVAC guide. So I just posted the link to the recording there. Asia asks if you can get a link to the builder's guide. So I'll link to that in our follow-up email. And Mohammed just asked, after heat load calculations, when it comes to air source heat pump selection, is there any requirements or limitations for supplementary systems in CSA F280? How large supplementary systems can be?
CSA F280, remember, is a heat loss, heat gain tool. It's not intended to influence your design decisions, right? How much supplemental heat, that's a design decision. It's not, your load calculation will tell you, here's an example, you need, say 48,000 BTUs to heat the home. You go through the selection process for equipment, and you decide, the best bang for my buck is, a 4-ton unit, but at the design condition, it can't deliver 4 tons. That's a nominal amount of BTUs at 47 degrees Fahrenheit or 8 degrees Celsius, right? But at the design condition, minus 22 or 25, it doesn't have that many BTUs left over. So I'm going to need supplemental heat, right? I can do it with a fossil fuel, or I can do it with electricity, right? Depends on how big the panel is, how much capacity you have on the system, and what jurisdiction you're in, whether they even let you use gas. And how much of it now is, at the very least, is the difference from the capacity that the heat pump can put out at the design condition and what the heat loss is. That might be, 5, 10, 15 kilowatts, depending. And then it's a decision of whether to provide just what you need to top up the heating system to deliver comfort at the design condition, or should you back up the whole system in case your heat pump fails, so you got backup system. That might be a good idea in remote locations. We're getting technicians out there on short notice. If something fails is hard, and getting parts is even harder, right? So you might want to fully back up the system. In other places where it's not hard, in bigger developed areas, you only really need to top it up. Or you could do something like you choose a heat pump, like a cold climate heat pump size, so that delivers the total capacity during design conditions. You don't even need backup or auxiliary heat. Now it's completely arbitrary whether you have it or not. That's so they're all in the realm of design decisions. The F280 only tells you what the load is for heating and cooling at the design conditions. It doesn't tell you how to design the system.
Great, thanks. And Mohammed says, thank you. All right, we have 3 minutes left. If anyone wants to squeeze a quick question in, we can answer it. I'll just give it a couple seconds there to see if anything pops up, or feel free to raise your hand. All right, I'm not seeing anything come through. Well, thanks so much, Rob, and thanks for everyone on this call. Thanks for a great discussion and all of your questions. And thanks for sharing your great wealth of wisdom with us, Rob.
My pleasure, my honor. Thank you so much.
All right.
Take care.
Thanks. Take care, everyone.